Our first featured talk tonight is from Shawn Young. Shawn is co-founder and CEO of Classcraft, a platform that helps teachers manage, motivate, and engage their students by transforming their classroom into a role-playing game. Since its launch in August 2014, Classcraft has gained incredible traction with educators worldwide. With a unique background in physics, education, gamification, and web development, Shawn's interested in how we can create community in the classroom and how games can make learning fun and interactive. Shawn taught 11th grade physics for 9 years, got a little experience, where he implemented innovative approaches to such as a flipped classroom, project-based and game-based learning. He holds a bachelor's degree in physics and a master's in education from Sherbrooke University. Shawn's also a seasoned web developer, working for clients such as Chanel, the Future of Storytelling Summit, Carnaval de Sherbrooke, Heido Quebec, and the Feast Social Innovation. He's also had speaking engagements across North America and Europe. At Classcraft, he leads product development, education, and game design, leading the development team and building out the tech that drives the game, designing new features, and coordinating educational research projects. And tonight, Shawn will tell us about scaling Classcraft. So, everybody, without further ado, please welcome Shawn.
Thanks, Nick. Hi, everybody. Welcome to Meteor Night. My name is Shawn Young, as Nick said. Tonight, I'm going to talk to you about Classcraft, what it is, and how we scaled to 600,000 users in the last 18 months, and some of what our challenges have been in terms of stack, and how moving to Galaxy has really helped us do that. So just to give you a bit of an overview, Classcraft is a free online platform that transforms any classroom into an immersive RPG. It's all built in Meteor. We have native web apps, native iOS and Android apps, and with a backend that's all driven by Meteor. We'll go a bit into what the app is a little later, but it basically has a very interesting scaling demands because one user, one teacher, it actually generates 100, 150 students. So for each user that comes on board, we're actually driving several hundred new users as well that all have similar usage patterns. So just to give you a bit of an overview, I founded Classcraft with my brother Devin here in the center and our dad, Lauren Young. Devin is the creative director for Classcraft, and Lauren does admin. We founded the company in 2013, at the end of 2013, but we launched our official product 18 months ago. So 6 months from founding the company to having an up-and-coming startup in education. We're based in Canada, but we also have a satellite office in New York City. So it started out the three of us. We're now 10 full-time staff. Our pricing model is a SaaS, so there's a free version with a premium version for added features at $12 a month. And we just closed up our seed round today for thanks. For $1.5 million in funding. So so this has been our traction. Kind of started off slow, and now we're up at just shy of 600,000 users. We're across the world in 75 countries. We're translated in 8 languages. And it's been growing a lot since the fall. We doubled our users just at the time we were moving to Galaxy. So this is about when we moved to Galaxy. So we were already at that time on our old stack, putting a lot of energy in maintaining that. And tonight I'm going to talk to you about how moving over to Galaxy solved a lot of those issues at a critical time for us, where we, basically were doubling our number of users. So just to give you a bit of a vision of what our traffic looks like, it's related to classroom usage. So we have people using it during the day very intensively, and then it dies off during the night and during the weekends. Very long session lengths as well. We'll have people who stay connected for an hour, for 2 hours, teachers with their students. And right now we're running something like 5,000 concurrent users at any given time, but it also spikes during the day. We can go up to 10,000 users. So intensive traffic at the same time during the day. but it's also a fairly complex app as well. So just to give you a sense, I'm going to just switch over here and show you a bit of what's going on. Basically, this is a teacher dashboard. Kids play in teams all year, and the goal for them is to gain great powers. So powers like being able to use their iPod during class time, or being able to eat in class, hand in an assignment a day late, real life benefits for them as learners. And the way they get those powers is the teacher gives them points for good behavior. So as they evolve through the classroom throughout the day, the teacher will give them points and they'll level up. They're also playing in teams, and if they do bad behavior, they can lose hit points and they can eventually fall in battle. So there's a lot of interaction going on between these users. So for example, this player could use his healing power on this player, heal her up, give her some HP. And so what we have is a lot of reads and writes between different users, all going on at the same time. For a group of users for a classroom, they'll all be logged in at the same time, using powers on each other. So very intensive app usage. There's also a lot of other stuff in here to complexify this even further. There's full-blown messaging. We have a place where teachers can put resources and users can comment it. So there's like an actual like discussions that are happening. We also aggregate data across the entire game experience. So we can build research reports for teachers that they can show to parents. So this is pretty interesting because we're aggregating here thousands and thousands of data points of things that happened in the game. And we have an aggregate for the player, but we also have an aggregate for his class. And we also have information on which ones come out more often for 3 different metrics. So there's some pretty intense lifting here happening, and it's happening pretty quickly, as you can see. This specific collection has over 25 million data points right now. It's the collection of everything that happens in the game, all the game logs. So there's a lot going on. Kids can also customize their characters, and as they level up, get cooler and cooler characters and customize them piece by piece. So a lot of interaction between users. And so we not only have a lot of traffic, but we have a lot of complexity as well. So when we first launched this, there weren't that many turnkey solutions for hosting Meteor apps. So we were running off of AWS. Obviously, we wanted to scale vertically, so we started using Passenger, which is a tool that allows us to basically create different app instances across processes. So at the end here, we had a very large single server, had 16 virtual CPUs with 2 app instances each. So that single server was running 32 instances of the same app. And it was working okay, but we were having a lot of issues as we were scaling so fast. So it was a lot of config to do. Load balancing was very tricky because we were load balancing across processes, and sticky sessions were kind of high. We needed sticky sessions, but we also needed to load balance, and it was creating a lot of conflicts between those 2 desires between each other. And at the same time, when we would deploy, it was pretty imperfect in terms of actually allocating users to the right processes, and then they would be on the wrong process, and because of sticky sessions, keep going to those processes. So we were having relatively serious memory issues, and because it was all on the same server, it was actually affecting our entire user base. So things with Galaxy are pretty different. The way Galaxy works is that you have separate containers. So each one is an allocated single app server that has 1 gig of memory, and basically it runs your app on that single container. And what you do is you have multiple containers, so it scales horizontally, and you can scale at will. And of course, in very Meteor style, they built it so it was no config, super easy to scale. And then there's a whole bunch of slew of features that are part of that that really answered a lot of the problems we were having. So I just want to go through some of those with you. One of the things that's really core about Galaxy is how easy it is to scale. Basically, you can spin up a new container instantly just with the press of a button, or scale up and scale down, depending on your needs. And then the load balancing in Galaxy works really well. So it will, if you provision new containers, it will then allocate new users to those containers. So as you get traffic spikes, you can scale up and allocate your new users to app containers that don't have anybody on them. You also get like this ongoing panel to tell you how many people are connected and where they're connected. So it scales really easily, but for it to properly allocate users, you also need something that's really core to that deploy process. So you're deploying code, but you don't want to disconnect everybody at the same time. What we were doing with our old app server was when we would deploy code, everybody would get disconnected. And then the server would spin up new processes and allocate people to those processes. And there was an issue there because as it was spinning up processes, maybe it would just spin up a couple, 3, and then users would start trying to connect, and they would all connect to the same 3 or 4 processes. And then the 30 other ones didn't have anybody going to them because they were now stuck on sticky sessions to these specific processes. And the way that Galaxy handles that is when you do a deploy, it'll spin up a new container. So spins up a new container, then moves users from one container to the other container, then destroys the old container, which has the old code, and then progressively does that for each container. So these are rolling restarts, but they're really important because what it means is a few things. The first thing it means is that your users don't get all disconnected at the same time. The second thing it means is that it's a lot easier on the database. One of the things we had when we would deploy on the old app stack was everybody trying to reconnect at the same time would cause like serious pressure on the op log on the MongoDB. So now what's happening is that because it's happening progressively, all those watchers aren't happening at the same time. And that really means that you can deploy during the day as opposed to waiting till there's nobody on the app. Another important thing is that it load balances properly across containers. So it'll look at which containers are being used and properly allocate users, as you would expect. But it also handles sticky sessions. So sticky sessions are the idea that you need process persistence. And that's really important because identity stuff of the user is carried over to the session server side. And if a user gets disconnected, you want to make sure that you're able to have them maintain a stateful connection. So if you have a single screen app, for example, like we do, you want to make sure that if there's a delay in connection, or if they're using long polling as opposed to a proper WebSocket, that they'll always be connected to the same server so that they maintain persistence of their session. So the idea is that if users get disconnected, they will go back to the same container where they were originally. So they're always connected to the same server. Another important thing about Galaxy, this is from the Galaxy dashboard, and this is for us was also critical. We were having, specific memory issues across specific processes, but it was affecting everybody. In Galaxy, we have isolated memory management. So what that means is we can control it on a container level, see where it's spiking, so that we can then see what's going on within that specific container and see where memory is being drawn. We can also see logs for that specific container as well, and we can also kill the container completely if we need to. And what that means is it allows us to delve a lot deeper in terms of, because you're scaling across 50 containers, for example, but they're not all doing the same thing at the same time because the users aren't doing the same things. And with this, what you're able to do is see what's going on in a specific instance and get very deep down in terms of managing your memory. It also means that if one of the containers spikes, or if there's a memory leak, it's not going to affect your entire user base. It's just going to affect the ones that are on your container. And Galaxy is pretty smart. If your memory starts going over the recommended limit, like if you go over a gig of memory usage, it will spin up a new container. So it'll spin up a new container, move your users that are experiencing degradation to the new container so that they don't have lag for extended periods of time if you have memory issues. So very important for us. It also has integrated plug-and-play SSL, so no setup there either. And it has single line deployment. Now we had single line deployment in our other stack. We had built our own deployment with Capistrano, which is a Ruby tool. It was good because we could just deploy. On the other hand, it was really annoying because we had to handle the whole build process of Meteor. So we had to build, our own tarballs, upload them, untar them on the server, start the app, and it was a little heavy, especially as Meteor evolved. We kept having to go back to this script and evolve it. So it was pretty heavy. It also didn't have user management, which I didn't realize we needed until we started scaling the team. Basically, anybody on the team could just type that and deploy straight to production. So I love my dev team and I trust them, but you want to make sure that you have proper access. So Galaxy has all that. So it has it tells you who deployed and when. It also has a single line deploy process. You don't have to configure it, which is nice. And it has user roles. You can it's related to Meteor dev accounts. So you can assign permission to specific Meteor developers to have access to your deployment process. So it means that you can make sure that not anybody can just call that if they have access to your code base. And again, no config. So the last part of the stack is the database, and this part is not part of Galaxy. This is just what we've been using since the beginning. We used a marketplace Mongo instance from AWS. They don't have it anymore, unfortunately. So it was great then because we just spun up this Mongo instance pretty quickly and we were able to use it. We have a fairly large DB right now, and it's still going strong. So it's a little annoying because we can't. Galaxy is not a one-stop solution, but in terms of the app server, it really is. So there's a few things that would be great to have in Galaxy. It's not all perfect. One of them is better monitoring tools, and I know that MDG is working on that, but we do still use Kadira for a lot of monitoring. And Kadira is great, but it's an external service, so it'd be nice to have that at the server level to be able to monitor what's going on with your apps in a better way. And then it's not a single standalone solution because you have to have a separate DB server, and you also, for us, we have a lot of helper tasks on a little server that runs cron jobs and cleanup tasks and stuff. So you can't just only have Galaxy, but I'm pretty confident that their vision is to make it a more of a one-stop solution. But right now, in terms of the app process, it's pretty solid. So just to give you an idea, before we were spending something like 10 hours of dev time a week on sysadmin, and sometimes way more than that if we had scaling issues. At the moment where we moved over to Galaxy, I was spending 30 hours a week debugging servers. And so, sysadmin is very cost prohibitive, takes a lot of time, and I don't know, I'm not the type of developer who likes doing that. And no joke, now we're putting 0 hours into sysadmin. Literally 0. I haven't done any sysadmin since September. So I think that in itself is a testament of how solid it is and how well it works in the Meteor ecosystem. I think as well, as we build apps, what we want to be focusing on is not sysadmin, but building rich products and meeting our users with what they need, as opposed to working in SSH, tweaking servers. So for us, this was a real boon, and it made it a no-brainer to switch over. And I think that a lot of developers would see it that way as well. So for us, what's next is we're going to be integrating with different partners. Google Education has a nice large teacher user base, so we're going to be looking at integrating with them. We're also going to be building out an API hopefully we'll have reactive endpoints. And then more game features to make sure that kids stay engaged. So that's it for us. If you want to find out more, you have our website, our email. Thanks for listening.
Questions for Shawn?
Yeah.
How much does it cost you to run this service?
Well, we paid for, I don't know if we have a standard package. We were part of like the original few companies that were there, and we paid up front for the whole year. But right now we're paying something like $1,500 a month.
Could you repeat the question, Shawn?
The question was, how much does it cost for what we have? So we have a fair amount of containers. I think most companies would have less containers than that because it's a very complex app in terms of user interactions. So I'm pretty sure it could be a lot lower than that for other people. But I mean, for us, just the dev time we're saving justifies it, the difference. We were paying on AWS for our single server something like $850 or $900. So, yeah.
Did you also consider other Mongo hosted solutions like MongoDB or part of the Galaxy itself or something like that?
We did look at other Mongo instance services. The question was, did we look at other Mongo possibilities for hosting our DB than AWS? We do have our staging services, our staging app. The DB is on Compose. We didn't feel the need to look for other solutions because right now it's just chugging along fine. I think as we scale, we may have to, and then we'll check it out. But for now, we didn't need to, so we didn't do it. Yeah.
Yeah, I'm curious if you have a sort of a broad number of containers and they're upgrading their code at different times or in sequence. At some points, you're going to have two sets of code.
Yeah.
Do you ever run into issues with the database, different styles of data store? Because of that, your business rules might be conflicting, or is that not an issue?
The whole deploy process across 50 containers lasts like 3 or 4 minutes.
Okay.
So it's not like this thing where for a few hours you have conflicting code versions.
Sure.
So we haven't really seen any issues there.
Okay. Nice.
The question was, as the code rolls out in rolling restarts, do you see problems with having conflictual code?
Other questions for Shawn?
Yeah.
How many times per day do you push code?
That depends.
What's the question?
The question is, how many times per day do we deploy code? Usually like once per day. We'll try and make sure that it all happens like when there's the least amount of users. Because even if you have rolling restarts and everything, you still want to like minimize as much as possible downtime. So we'll do that, around midnight type of thing. But sometimes we've done it like 3 or 4 times in a day if we had severe bugs we needed to fix, and it was not an issue. Yeah.
Sorry, do you do staging before you actually deploy?
Do we do staging before we actually deploy? Yes and no. We'll do like hot fixes and just put them right into production, and just like if it's one line of code. If we're doing large feature rollouts, then yeah, we'll push it to our staging server, and then test it out, and then push it over to the production. Our staging server is on Galaxy as well. Like when you pay, you get a fixed number of containers, and you can spread that across multiple apps. So you could typically run 3 or 4 apps if you wanted on your single subscription. So what we have is the staging server has like a couple of containers, and it's just so we can test stuff. Yeah?
Yeah, did you guys plan on having like different game themes in the future, like for different age groups, or is that mostly just focused on this right now?
So the question is about the product. It's do we plan on having different game themes? Yes and no. Yes, we do. Not soon, because it's actually so we have somebody working full time just drawing these characters, and it's actually a lot of work. Especially if you want to keep up this level of like detail and quality. Like this is, looks like a real video game. And when going to, students, that's really important. when you say, oh, we're going to turn class into a video game, if it doesn't look like a video game, then they'll be like, yeah, whatever. So the short answer is yes, we would love to do that, especially, we could easily like swap this out for like a sci-fi type of theme or a more young child friendly type of theme. But right now we're still fleshing this one out.
We got time for one more question.
Who raised their hand first? Okay.
How many concurrent users are you getting per container?
So we have like an average of like 50 or 60 containers running, and we'll typically go from 5,000 to 10,000 concurrent users. So we're talking like 100 to 200 concurrent users per container. The question was how many concurrent users per container? Yeah.
What's the age range of a user? What's the normal average?
So the question is, what's the age range of our users? Actually, the game is really customizable. So we have people using it from grade 3 all the way up to college classes. We also have enterprise level people using it in their company to gamify their staff. We have people using it at home with their kids. Because you can customize all these rules, why you gain points, what the powers are. Typically in K to 12, the average age is 14. But there's like a huge like curve around that.
All right. Excellent. Thank you very much, Shawn.
Thank you so much. I'll be around if you have other questions.